Welcome to the SQL Server Fast Execution Plan video training, presented by Hugo Cornelis. In block 6 of this course, we discuss all operators related to sorting and grouping of data. The latter category includes both aggregation and segmenting. The first chapter discusses the stream aggregate operator, one of two operators that can perform aggregation. It can compute the basic aggregate functions, such as count, max, or sum. Some other aggregate functions are computed indirectly. For instance, the average is the sum divided by the count. The stream aggregate algorithm requires that the input data has to be sorted by the group by columns. If that condition is met, then the aggregation itself uses a very cheap and effective algorithm. We will also look at a few special cases, such as aggregation without aggregate functions or without a group by clause. In Chapter 2, we look at the other aggregation operator, hash match aggregate. This is in fact the same operator we already saw in block 3, but now with a slightly modified algorithm that uses just a single input and aggregates its input data. Unlike stream aggregate, hash match does not require its input to be sorted. The price for this is blocking behavior of the operator, increased CPU usage and high memory requirement, though not as high as when hash match is used to join data. The sort operator is covered in Chapter 3. It does what the name suggests. This means that it has to process all input data fully before it can return any data. The consequence of this is that we need to store this data somewhere. Ideally, in memory, which means that the sort can result in a large memory grant for your execution plan. And if at runtime the granted memory turns out to be insufficient, the algorithm will spill to TempDB, which slows down the operation by a lot. For these reasons, the optimizer tries to avoid sort operators when it can. If a sort cannot be avoided, it can sometimes be combined with another operator. This results in the logical operations distinct sort, which removes duplicates from the sorted data, and top n sort, which returns only the first few rows from the sorted data. Chapter 4 covers the segment operator, which is used to identify segments in the data. The method used is simple. The operator simply adds a new column that is set to 1 on the first row of a new segment and to 0 on all other rows. By itself, this is meaningless. It becomes relevant because the parent operator of a segment operator adapts its behavior based on that segment column. For instance, the sequence project sets or resets its internal counters based on 1 or 2 segment columns. In more complex queries, the optimizer is not always able to reorder operations for the most effective processing, so we look at some guidelines for rewriting queries that might save performance. Finally, in Chapter 5 we talk about window spool. This operator is used to process aggregations over a window frame. This operator requires a very specific set of columns in its input to guide its behavior. Based on those columns, it stores the input in a work table and then returns sets of rows that consist of the current row, followed by all rows in the visible window frame. A stream aggregate operator then condenses each such set back to a single row with the requested aggregate values. For the most common use case of window frames, running totals, the amount of work can get quite high. To reduce this, Microsoft has implemented a more efficient special case handling for this use case, called Fast Track Optimization. These 5 chapters make for a total viewing time of over 2 hours and 40 minutes. This overview merely touched the surface of everything I describe and show in the videos. If you want to know more, then you should definitely check out the full videos for the basic level of Block 6, sorting and grouping.